loves, we're going to go over Newton's third law of motion. So this is Unit 4, Lesson 12. So if you lean over, you fall over. If you lean over with your hands against the wall, you don't fall over. Why? Because the wall is pushing on you and holding you in place. So our objectives for today, we're going to explain Newton's third law of motion. We're going to look and interpret diagrams that demonstrate the applications of Newton's third law. We're going to apply the three laws of motion in real-world situations such as sports activities and transportation. So action and reaction. So Newton's third law describes something else that happens when one object exerts a force on another object. So according to Newton's third law of motion, forces always act in equal but opposite pairs. So another way of saying this is for every option, there's an equal and opposite reaction. This means that when you push on a wall, the wall pushes back on you with a force equal in strength to the force you exert. So Newton's third law of motion states that when one object exerts a force on a second object, the forces are equal in magnitude and equal in direction. Alright, so we're going to look at action and reaction. Forces don't cancel out. A lot of people like to say they cancel each other out, but they don't really cancel each other out. We'll talk about that here. So forces exerted by two objects on each other are often called an action and reaction force pair. Either force can be considered the action force or the reaction force. So action and reaction force pairs don't cancel because they act on different objects. So why do equal forces not cancel to zero? There are many equal and opposite forces in a system. So you can think about it as two people kick the ball at the same time. Together, they cancel each other out. So here you have foot A and foot C at the same time hits the ball B. And if they hit at the same time at the same angle, but in opposite directions, the ball's not going to go anywhere. So you consistently use action-reaction force pairs as you move about. Okay? When you jump, you push down on the ground, and the ground pushes up on you. It is this upward force that pushes you into the air. So when a bird flies, its wings push in a downward and backward direction. This pushes air downwards and backwards. By Newton's third law, the air pushes back up on the bird in the opposite direction, so it moves it up and forward. This force keeps a bird in the air and propels it forward. So during a softball game, a shortstop fields a ground ball. The action force is the ball pushing on the glove as it enters the shortstop's hand. So what's the reaction? Well, if the action is the ball pushing on the glove, you can think about one is the ball acting with or is acting with the glove. So the reaction then is the glove pushing on the ball. So when you walk forward, you push backwards on the ground. So your shoes push the earth backwards, and the earth pushes your shoe forward, so that's going to move you forward. So Earth has so much mass compared to you that it does not move noticeably when you push on it. So if you step on something that has less mass than you do, like a skateboard, you can see it being pushed backwards. So whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. So here we have a person who's stepping off their skateboard, and as they push back on the skateboard, since the skateboard has less mass, it's actually going to roll in the opposite direction. So in a basketball game, a player shoots a jump shot. What force actually causes the player to jump? Well, it's going to be the floor pushing up on the player as the player is jumping, and that's going to help cause the player to jump. So action force, reaction force. It doesn't matter which is which. Partners in interaction, so they're going to be equal and opposite, and neither can exist without the other. So here we have a balloon. So we blew it up, we let it go. So the action is the air rushing down, reaction is that the balloon goes up. So this is kind of exactly how rockets use. So when rocket fuel is ignited, a hot gas is produced. So as the gas molecules collide with the inside engine walls, the walls exert a force that pushes them out of the bottom of the engine, giving it that lift. So this downward push is the action force. The reaction force is the upward push on the rocket engine by the gas molecules, and that's what gives the rocket its push to go up. If the force of a golf club on a golf ball is 200 newtons forward, what would be the force of the ball on the club be? So let's picture this. So we have the club, we have the ball. The club is going to put 200 newtons on the ball, so how much force is going to go from the ball back to the club? Remember that they're equal and opposite, so it's going to be 200 newtons backwards. Okay, so they're equal, but they are opposite. You might have seen pictures of astronauts floating inside a space shuttle as it orbits the Earth. And we say that they're weightless, yet the force of gravity on the shuttle is almost 90% as large as the Earth's surface. So Newton's law of motion can explain why the astronauts float as if there were no forces acting on them. Because remember, to get weight, their mass doesn't change, but to get weight, you have to have that gravity. So let's picture this. So you're standing on a scale, your weight is pushing down on the scale, and that's what gives you your weight. The arrow moves and it tells you how much you weigh. So at the same time, by Newton's third law, the scale pushes up on you with equal force to your weight. So this force balances the downward pull of the gravity on you. And now suppose you are in an elevator and the elevator starts to fall. So the falling object is in free fall, and when the only force acting on the force is gravity. So gravity is the only thing that's going to be affecting you, but you're both in free fall. Because only the force acting on you is gravity, the scale no longer is pushing up on you. And according to Newton's third law, you no longer push down on the scale. So if the scale is not pushing up on you, you're not pushing down on it, which means the scale is going to read 0 and you're going to seem like you're weightless. So action equals reaction. So if you hit a wall, it's going to hit you back, and you can never hit the wall harder than it hits you, because it's always equal and opposite. So if you hit a piece of paper, because of how light it is, it's not really going to hit you back as hard as the wall. So in conclusion, if you push the world hard, it's going to push you back hard. If you push the world gentle, it's going to push you back gentle. And you cannot touch without being touched. So if you are touching your couch, you're touching it and it's also touching you with the same force that you're touching it. Alright, this one here can be a little tricky, so if you do have any questions, please make sure that you stay after class and ask, or send me a K-mail. Thank you.